So the next thing we can do with cot and cosec and sec is to learn some new trig identities. So everybody knows and loves that sine squared theta plus cos squared theta equals 1. Okay, that is a given fact that you all know off by heart. We can turn that fact into two other facts. So the first way we can do it is if we divided this expression by sine squared theta. So sine squared divided by sine squared is 1. Cos squared divided by sine squared is cot squared. And 1 divided by sine squared is cosec squared. So there is a brand new trig identity. We can do the same, but instead we could divide it by cos squared. So sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is sec squared. So that is another trig identity. So actually, you don't need to learn those, you need to learn this, and you can easily derive or easily prove these by just dividing the expression that you know by cos squared to get this one, or dividing it by sine squared to get this one. This one is the one we use most often because I'm not sure if Mrs. Morrison has shown you in the quotient rule, but when you differentiate tan, you get sec squared. So this one comes up a lot to solve problems to do with differentiation. If she hasn't done that with you, don't worry about it yet. We will come over it, but this one is the one we use the most regularly. To kind of compensate from that, I'm actually going to use this one in our examples to make sure that you get a good mixture of both. So let's try a couple. Okay, let's try this one. Solve for cosec squared theta minus 9 equals cot theta. So in our starter we had, I can't remember what we had in the starter. Was it sine squared and coses, or cos squareds and sines? I can't remember, but we used the identity sine squared plus cos squared is 1 to turn them all into the same trigonometry. So here we're going to do something very similar. So we know that sine squared plus cos squared is 1. We're looking for something with cosec in, and cosec is 1 over sine, so we are going to divide this identity by sine squared. Sine squared divided by sine squared is 1. Cos squared divided by sine squared is cot squared. And 1 divided by sine squared is cosec squared. So here's a new identity which I can use to turn a cosec into a cot, which is what I've got over here. So cosec squared theta is the same as 1 plus cot squared theta. So I'm going to swap that in. So all I've done is taken that cosec and swapped it for a 1 plus cot squared using this identity. If I multiply this out, I've got 4 plus 4 cot squared theta minus 9 equals cot theta. So I'm going to rearrange this, bring it all to this side. So I've got 4 cot squared theta minus cot theta, minus 9 plus 4 minus 5 equals 0, which is a quadratic. So let's try it with 4 first. Remember, if factorising it this way doesn't work, you could try it with 2 and 2 instead. No, that will work. So if I put minus 5 here and plus 1 there, I get 4 cot squared theta minus 5 plus 1 cot, so minus cot minus 5. So I've missed the thetas off, sorry. So cot theta is 5/4 from this one, or cot theta is -1 from this one. Because cot is a reciprocal function, we can take the reciprocal of both sides. So tan theta is 5/4 by reciprocal of cot and reciprocal of this. And tan theta is -1/1, which is -1 from the reciprocal of that. And then, I didn't say whether I wanted it in radians or degrees. Let's just go with degrees because I'm already in degrees. So if we inverse tan 4/5, we get 38.7. Remember, for tan, to find your other solutions in the range, you just add or subtract 180. So I'll say let's go from 0 to 360. So you get 218.7. And on this one, if I inverse tan -1, I get -45, which is not in my range. So I'm going to add on 180, which is 135. And I'm going to add on 180 again, which is 315. So that would be all my solutions in my range 0 to 360. Okay, so it's not a big step from what you did before. You just have the identity that you know, you turn it into a new one and substitute it in exactly the same way as you did the starter. In the starter, sorry. Okay, and another one we could look at is we could say prove cosec to the power of 4 theta minus cot to the power of 4 theta is exactly equivalent to 1 plus cos squared theta over 1 minus cos squared theta. Okay, right, so the first, I imagine the first stumbling block you would come across here is not spotting that that's the difference of two squares, because it's kind of like a disguised quadratic within that. So I could rewrite that as cosec squared theta plus cot squared theta times by cosec squared theta minus cot squared theta. So that would be my first thing to do, I think. I'd probably also have a look at this and say it's causes. I probably would want to, I don't know, my instinct would be to get rid of these cots here if I can. And to do that, I would be remembering that sine squared plus cos squared is 1. I've got cosecs here, so I'm going to divide by sine. So if I divide that by sine squared, I get 1. If I divide by that by sine squared, I get cot squared. And 1 divided by sine squared is cosec squared. Sorry, made a mess of that. So it's a bit scribbly, sorry. 1 plus cot squared is cosec squared. So I might say now that cot squared theta is cosec squared theta minus 1. That's probably where I would go with that. So cosec squared theta plus cot squared theta, so plus cosec squared theta minus 1. So I've swapped that for that. On this side, I've got cosec squared theta minus this, so minus cosec squared theta, minus 1, plus 1. So this bracket, those two disappear and I'm left with 1. So this bracket is just worth 1. So if you times this by 1, you just get what it is. So I've got cosec squared theta plus cosec squared theta, which is 2 cosec squared theta minus 1, which does not look anything like that. So I know that cosec is 1 over sine, so 2 cosec squared is 2 over sine squared theta minus 1. If I times this by sine squared over sine squared, I've got 2 sine squared theta minus sine squared theta over sine squared theta. So on the top, I've got 2 minus sine squared theta, and on the bottom I've got sine squared theta. Sine squared from this identity here is 1 minus cos squared. So I could put that in. So 1 minus sine squared, which is 1 minus cos squared. On the bottom, sine squared is 1 minus cos squared. Oh, here we go. So I've got 1 minus cos squared on the bottom. 2 minus 1 is 1. Minus minus makes a plus. Plus cos squared theta over 1 minus cos squared theta. That did not feel very neat, so it's possible that you could have done that in a more concise way. But that's the thing with these identities. Sometimes you can go around the houses a little bit and get to the to the answer quicker. I'm going to put some questions on now. I'm just going to show you in the textbook actually. And I am not going to show you the answers. And the reason I am not going to show you the answers or show you how to do the answers is because I want you to persevere. I know that you find the trig stuff really hard, and I know that if I give you a video of the answers, the inclination is for you, understandably, to maybe not persevere as much as you should and to think, oh, this is too tricky, I'm going to go to the answers instead. You know, when I got to here, this does not look like where I want it to go, but I can do something, I can carry on, and I can get it to where I need it to be, but I have to persevere. And that's what I need you to learn. Now, I think, not 100% sure, but I think next week is a consolidation week. So I'm going to give you this work with no answers. I want you to have a go at it this week. Then next week, I want you to come back and have another go at it in consolidation week. And then I'll send you the answers, a video of the answers towards the end of next week. So hopefully you can see this if I put it in here. So I would like you to do question 6 and question 8, but only up to, let me think, up to F. So all of question 6 and question 8 up to part F. Okay? So pause that if you need to, or take a screenshot or whatever you need to do, but all of question 6, question 8 up to part F, I want you to try them today, and then I want you to try them again next week, because if the biggest thing I can teach you with trigonometry is to not give up and to just persevere. Try something a different way. See if you can swap something else in. It's all the only way you're going to get good at this is to practice and fail at it and try again. And I know that sounds horrible, but we said this when we did the normal trig identities at the beginning of the class. It is universally the thing that people find the most difficult, and you just have to not give up with it. Okay, I know that's really hard. I know it's even harder when you're at home working on your own, but do your best and then walk away, have a cup of tea, come back in a few days' time and try again. And the more you can do that, the better you will get. I promise. Okay, have a good week.